2.8 is a very special section because it's the last section that will be on the test. So this homework's due Monday, and that means on Monday night, your only homework will be to study.
Wait, there's no. Wait, there's homework. Isn't that homework due tomorrow? Or Monday?
Yes, 2.8, because it's on the test.
Yeah.
But no homework will be due on Tuesday, the day of the test.
Okay.
All right, 2.8 is about algebra of functions. Basically, we want to combine other functions or split them up in creative ways. So first thing I'm going to do is define f of x to be 2x squared, just this portion, and g of x I'll define to be negative 5x plus 2. And I'll define k of x to be the opposite sign, 5x minus 2. So one way I can decompose this function is to rewrite it as f of x plus g of x. So that would be 2x squared plus negative 5x plus 2. All right, do we see why this is equal to h of x? Okay, so we can combine functions to create another function or decompose h into two separate functions. How can I combine f and k to create h? So in this case, we could subtract k, and that should give us the original h function. That would be x squared minus, and we put k of x in parentheses, 5x minus 2. And after you distribute, we get 2x squared minus 5x plus 2x. Sorry, plus 2. So it's not unique. There's many ways to break up a function. In fact, infinitely many ways. There are a few things we need to watch out for when we add functions together or subtract them. When we multiply them and dividing them is especially worrisome. Okay, so when you add them, you just add the terms together as we did, or subtract them, you just subtract them. But the domain may change. Okay, so what we'll want to keep in mind is the domain of adding, subtracting, or multiplying functions is going to be the intersection of the domains of the individual functions. So the domains of these will be the domain of f intersected with the domain of g. You guys recall what intersection means? The intersection of two regions. It means and. So if you have an and between two inequalities, are we talking about the overlapping region or anything in either? I'm going to pull back the notes. This is something you'll want to highlight. Where did we talk about inequalities? 1.7? All right. This is something a lot of you, if you didn't answer in your head, will want to highlight in your notes. Intersection means what?
They overlap.
They overlap, yes. We want the overlapping domains of each one separately. The overlap. Let's just deal with that before we talk about f divided by g. So we have our first example. F is the square root of x minus 3. G is x squared minus 9. Let's talk about what is f plus g of x. It's the same as f of x plus g of x, which is equal to square root of x minus 3 plus x squared minus 9. Any questions about that so far? Okay, a little bit of review from before. How do you find the domain of a square root function? What's the domain of function f? What's on the inside cannot be what? Negative. Can it be 3? Yeah, square root of 0 is 0. Okay, it can't be negative, so how do I specify it's positive? Make it greater than or equal to 0. I am getting a little bit worried about this test because I'm asking some review questions and definitions. We've done this on previous homework assignment. What is the domain of a square root function? Take the inside, you set it greater than or equal to 0. Because you can take the square root of a positive, not a negative. Okay, we add 3 to both sides. X is greater than or equal to 3. And so what is that in interval notation? Yeah, everything larger than 3. 3 to infinity. Do you guys need me to graph it on a number line first? Okay, we're okay with that. 3 to infinity. Do I include infinity? Never. 3? Yes, because it says x can equal 3. This is the domain of function f. What is the domain of function g? The domain is all values of x I can plug in that will result a real number. I had to take out negatives for square roots because square root of negative is not a real number. It's imaginary. The only thing I have to worry about is square root of negative numbers and division by 0. I can square any real number and it's a real number and subtract 9, it's still a real number. So the domain of a polynomial is all real numbers. The domain of g is negative infinity to infinity. I only have to worry about fractions and square roots. Now, what is the domain of f plus g? The domain of f plus g is equal to the domain of f intersected with the domain of g, which would be what? It's the overlap, right? So if I look on my number line, here's 3 to infinity, here's negative infinity to infinity, and the overlapping region is 3 to infinity. Any questions so far? All right, f minus g. It's just square root of x minus 3 minus, please be careful about subtracting. You want to put it in parentheses because we have to distribute the minus sign. X squared minus 9. What's the domain of f minus g? Intersection of f and g also. So this has the same domain as that. Are we okay with that? Okay, what's function f times function g? It's square root of x minus 3 times x squared minus 9. And the domain of that is the intersection of the domain of f and the domain of g. So I guess I'll write those explicitly. The domain of f minus g is equal to the domain of f intersected with the domain of g, which is also 3 to infinity. We already computed that. And likewise, the domain of f times g is equal to the intersection of domain of f with the domain of g. That is also 3 to infinity. Now let's talk about the last scenario. What problem might arise when I divide the two functions? What's that? Yeah, what kind of domain error? Undefined, yes. When you divide by 0. So we have square root of x minus 3 on top, divided by, on bottom, x squared minus 9, which if we factor the denominator, what do we get? X plus 3 times x minus 3. So the domain error is when the denominator is 0. We know that x plus 3, x minus 3 cannot equal 0, which means x cannot be negative 3 and x cannot be positive 3. So this is the one extra thing, because we're dividing by a function, we have to watch out when denominator is 0. So the domain should still be the domain of f divided by g should still be the intersection of the domain of f and the domain of g, but I must eliminate when g of x is equal to 0. So if I wrote these out explicitly, we said the domain of f is 3 to infinity, said the domain of g was negative infinity to infinity, but now we're going to subtract which values? Negative 3 and 3. So that intersection was what? Just 3 to infinity. So what do we need to throw out? Just 3, right? Because negative 3 is not in there. So we need to throw out 3. So our domain is 3 to infinity with a parentheses. Any questions about that? Example 2 is more simple. We're just plugging in the values. So what's f minus g of -1? That's the same as f of -1 minus g of -1. So the function f, I'll just plug it in parentheses, would be -1 squared minus 3 times -1 plus 2. We'll plug -1 in for the x's. Any questions so far? And g of -1 would be 2 times -1 minus 4. So following order of operations, -1 in parentheses squared, 1, -1 times -3 plus 2, we get 6, right? And we have a minus 2 times -1, -2 minus 4. 6 minus -6 is, any questions so far? Significantly easier to just plug in and chug as opposed to finding the domain. Takes a lot of extra thought there. F times g of -3. I'm just getting used to this new notation. This is f of -3 times g of -3. Maybe I should color code it. F of -3, g of -3. Okay, so f of -3 would be -3 squared minus 3 times -3 plus 2. And we compute that in parentheses before we multiply it by g of -3 is 2 times -3 minus 4. All right, so in green, -3 in parentheses squared is 9. -3 times -3 is 9. So we get 20 times 2 times -3 is -6 minus 4, -10, and our final answer is -20. I don't know. Is it? I think you're right. Thank you. Yes, -200 is the answer. All right, f over g of 1/2. Do we get the pattern here? Just do f of 1/2 divided by g of 1/2. F of 1/2. 1/2 squared minus 3 times 1/2 plus 2 all over 2 times 1/2 minus 4. What's 1/2 squared? 1/4, 3 times -3 times 1/2. -3/2 plus 2 over 1 minus 4. Let's get a common denominator. Times 2 over 2, and we'll multiply this one by 4 over 4. What is 1 minus 6 plus 8 over 4 all over -3. So that's 9 minus 6 is 3/4 divided by -3 is the same as multiplying by -1/3. And our answer is -1/4. All right, let's see who's been paying attention. What's the domain of function f? Yes, all real numbers, because it's polynomial. You can square any real number, it's real. Fact 3 times real number, it's real. Add 2 is real. I don't have a square root, I don't have a fraction. All real numbers. Domain of g. All real numbers. What's the domain of f minus g? Intersection of both those, all real numbers. Domain of f times g. Domain of f divided by g. So we have to throw out where the denominator is 0. When is g 0? Yeah, so when x is 2. 2x minus 4 is equal to 0. 2x is equal to 4, x is equal to 2. Throw it out. Domain would be 2 union 2 to infinity, not including 2. So it's parentheses. All right. The difference quotient. We all need to memorize this. Have you heard of the difference quotient before? What does the word difference mean? Subtraction, quotient, division. There's a subtraction and there's a quotient. Where does this come from? If I have an ordered pair, x and f of x is a y value, is xy, right? What if I want to go a little bit to the right? Let's say I want to go h units to the right. Then if this is x, or this is 5, it would be 5 plus h. You just add it, so x plus h. How do you find the y value when the x value is x plus h? How do you find the y value? You plug it into the function, f of x plus h. We have two ordered pairs. P is x f of x. Q is x plus h, comma, f of x plus h. The secant line is the line between those 2 points. The only thing is the points have to be on our function. All right, here's a review question. How do you find the slope between 2 points? Yeah, very good. All right, we know that one. M is equal to y2 minus y1 over x2 minus x1. What's y2? Yes, f of x plus h. Minus, what is y1? Very good, f of x. What is x2? X plus h. And what is x1? Yeah, x. Very good. Hey, look at that. The x's cancel, and we get the difference quotient. F of x plus h minus f of x over h. So this represents the slope of this secant line, which is just y2 minus y1 over x2 minus x1. How many of you are going on to take calculus at some point? Okay. This is the first lecture in calculus. We would like to know the slope at this point. I would like to know the instantaneous rate of change, or the slope of this, which is called the tangent line. It just barely kisses the function at 1 point only. For the secant line, that slope we know from algebra. And you can calculate it. And we say the slope of the purple line is approximately the slope of the green line. Are you okay with that? If you had to estimate it, what would you say the slope of the green line is? Is it maybe slightly larger than 1? Maybe 1.5? What's the slope of the purple line? Slightly less than 1? Negative 0.8, something like that? Okay, the trick that we use is we say, let's just make h a little bit smaller. We move over here. Can you imagine the new secant line? I'm just going to drag this point over here, and now my new secant line is this red line. How's that slope match up with the green line? It's closer. What if I want to be more accurate? Make h smaller, and it's closer. What if I want to be infinitely accurate? Let h go to 0. Get infinitely close. So that's the calculus concept. You take h to 0. We call that a limit. Do you see any problem here about making h go to 0? The denominator would go to 0, and the universe explodes. Can't divide by 0. So the skill that you have to know how to do is implement the difference quotient, do algebra to cancel that h, so I don't divide by 0. If you're really curious about this, you can click this link, and it brings you to really cool applet. Let's show the tangent line. Maybe let's move a over. Okay, so how do we read this? H is 2, so if I go 2 to the right, the blue line is my secant line, the red line is my tangent line. So let's make h smaller. And what happens is I drag h closer. Do you see how the secant line becomes a better approximation of the red line? Until it goes to 0. And then it's exact. All right, so let's actually do an algebra problem, how do we apply this? The question's asking, find the difference quotient of this parabola, 2x squared plus 4x minus 3. So I need to apply this formula. Let me color code this. F of x plus h minus what? F of x all over h. Okay, so from the lecture on functions, what is f of x plus h? Do you remember how to evaluate that? Do you know how to evaluate f of 2? I would just plug 2 in for x's, right? How do you evaluate f of heart? You plug in the heart? You're okay with that? Yes, very good. Function of love. All right, so let's plug in x plus h here, and we get 2 times, instead of hearts, we have x plus h. Any questions about this? And we simplify. Are we at the point where we can do x plus h squared in our heads? Oh, thank you. -1 for Professor Rowell. I'm grading myself. Okay. What is x plus h in parentheses squared? FOIL it. Very good. Can we FOIL that in our heads? Or should I write the work? X plus h times x plus h. What's x times x? X squared. What's x times h? xh. What's h times x? xh. What's h times h squared? So I get x squared plus, good, 2xh plus h squared. We still have the 2. Here, let's distribute the 4 plus 4x plus 4h minus 3. Let's distribute the 2. 2x squared plus 4xh plus 2h squared plus 4x plus 4h minus 3. Are there any like terms that I can combine? No. They all have different variables or different powers. Can't combine any of them. So I'm just going to plug that in for x plus h. 2x squared plus 4xh plus 2h squared plus 4x plus 4h minus 3. And we subtract, what's f of x? Minus 3. And we still have the h on the bottom. Then we distribute that minus sign and we simplify. 2x squared plus 4xh plus 2h squared plus 4x plus 4h minus 3 minus 2x squared minus 4x plus 3. Do we have any like terms? Yes. What? What's 4x plus negative 4x? 0. Any other like terms? 2x squared and negative 2x squared adds to make 0. Any other like terms? Negative 3 plus 3 is 0. So it turns out when you do this, all the terms that don't have any h's are going to cancel. So it looks like 4xh plus 2h squared plus 4h over h. I said I want to get rid of the h on the bottom. Does anyone see how we could do that? Yeah. How do we simplify? If they all have a common factor of h, I could factor it out, and I would get 4x plus 2h plus 4 all over h. Then these reduce. Once you've done that, you got rid of the h on the bottom, you're done. 4x plus 2h plus 4 is our answer. You found the difference quotient, which represents the slope of the secant line at any point x. Now you can find the slope of the tangent line by taking h to 0. All right, any questions about this process? All right, the next thing we're talking about is composition of functions. So not only can we add, subtract, multiply, and divide functions, we can plug one function into another. That's what's called composition of functions. It combines the output of one function and becomes the input of another function. So this notation will be f composed of g. That is telling us, by definition, you plug function g inside of function f. And yes, we do have to worry about domain issues. So I'll talk about that after we do some computations. Let's first do example 4. What is f composed of g? It is f with function g plugged in. I'll say g of x plugged into f of x. So just like I asked, what is, actually, let's plug in. Okay, function g is equal to x plus 2. So just as we plugged in before x plus h, now we're plugging in x plus 2. Are you okay with that? Can you guys compute that on your own? All right, let's race. You plug it in and I'll plug it in, and let's compare answers. And when you're done with that, try g composed of f. Were we able to get this answer without making an error? So f composed of g just means take g, x plus 2, and plug it into f. So what if we have the opposite order, g composed of f? G with function f plugged inside. This one's a little bit nicer, huh? X squared plus 4x minus 1. And so function g is just x plus 2. But instead of x, we're plugging in x squared plus 4x minus 1. Yeah, x squared plus 4x plus 1. Very different answers, depending on which order we plug in. Any questions about that? Okay, example 5. I'm just going to do the faster method for this one. G composed of f of -1. So that's what this means. And we compute f of -1 first. That would be 2 times -1 plus 3. And what does that simplify to? -2 plus 3? 1. All right. And then g of 1, x squared minus 5x, but we plug in 1. And our answer is 1 squared minus 5 is -4. Any questions so far? Did I mess up? It happens. All right, example 6. We have to worry about the domain. Given function m of x equal to 1 over x minus 5, p of x is square root of x minus 2. M composed of p of x is function m with p of x plugged inside. So in this case, we would get m of square root of x minus 2. And function m is equal to 1 over whatever's plugged in minus 5. Well, the thing that's plugged in is x, square root of x minus 2. Okay, so if we're finding the domain of this new function, we look at the original that's plugged in. We're really worried about the domain of what's plugged in first. At this point, we all know how to find that. What's the domain of square root of x minus 2? Yes, you take the inside, x minus 2, it must be greater than or equal to 0. Otherwise, I can't take the square root of it, because it would be negative. And we add 2 to both sides, x greater than or equal to 2. So what's that domain? The domain of function p is 2 to infinity. Now I have to worry about the range of that being in the domain of the new function. So now I have to worry about the new function. When is that 0? root of x minus 2 minus 5. That can't be 0, right? We'll throw that out. How would we solve a square root equation? You all did it on your worksheet, right? You first what? Add 5 to both sides. Then you square both sides. And then, oh yeah, add 2 to both sides. I made a mistake in my notes. Okay. Any questions about that? So I need to throw out 27 in my interval 2 to infinity. So the domain of M composed of P should be what? So it's, oh yeah. This is saying negative infinity to 27, right? But actually, let me just talk about this number line here. Here's 2 to infinity. Here's 27. But I need to throw that one value out. So the domain of M composed of P is this interval, which is 2 to 27, not including 27, parenthesis, union 27, not including 27 to infinity. All right, we need to do this last example by reading the graph. F plus G of 1 is equal to F of 1 plus G of 1. Can anyone tell me what F of 1 is? When X is 1, what is F of 1? Yes, very good. It's 4. But what's G of 1? When X is 1, what is G? Negative 3. And so the answer is 1. Very good. All right, what about F of 0 times G of 0? What's F of 0? So when X is 0, what is my F function's height? It is 4. What is G of 0? X is 0. What is G? Yes, negative 4. And my answer is negative 16. Okay. Here we have G of negative 3 minus F of negative 3. What's G of negative 3? So when X is negative 3, what is G of negative 3? Negative 1. What's F of negative 3? So if I go negative 3, oh, my function doesn't exist here. It's undefined. So the whole thing is undefined. All right, lastly, we have F composed of G of 3. So what is G of 3 equal to? G of 3, that's right, is negative 1. What's F of negative 1? So if I go X is negative 1, what's the height of my F function here? 3. All right, the last one we'll do is G composed of F of 4. G of F of 4. So what's F of 4? I go to X is 4. And what's my Y value? 0. That's right. And G of 0. So when X is 0, what's the height of my G function? Negative 4. And we're out of time. Yes. The last one's undefined. I'll have you check that out though.